Okay everyone, welcome. Today I'm going to show you how to take your coaster here in Rhino and turn it into an STL file so that way we can upload it and import it into Bambu Slicer, but also into Ultimaker Cura, so that way we have files where we can print it on our Bambu P1S or one of our two Ultimaker models. So here I am in my Rhino file. I've got all three of my coasters in different variations. This one here is for laser cutting, this one here is for 3D printing, and this one here is for CNC. So what I'm going to do is I'm going to grab my coaster. It's best to have these things centered at the origin, but since I have all three of these coasters, I'm going to leave this 3D model where it is. And I'm going to go ahead and type in export. That's the command I want to use. And what I want to do is I want to thoughtfully put my file and organize it somewhere so that way I can find it easily later on. So I'm going to put it right here, 3D print. I'm going to give it a name and change the date to the 17th. Coaster assignment, 3D print. And the important thing is to export this file not as a Rhino file. If you export as a Rhino file, you're basically just saving it as a Rhino file. What we want to do is export as a STL or stereolithography file. So right there, STL. So we're going from 3DM, we've got a 3D object, we're going to STL next. Go ahead and save that. Go ahead and hit OK on this first dialog box, and then OK on this second dialog box. And then you're also going to want to download Bambu Studio and Ultimaker Cura if you want to use your own personal computer to slice your projects. And if you have a personal computer, I highly recommend you do this. However, if you are dependent on using the computers here at school, we do have both of these slicers installed on all of our computers here in the architecture department and also in the makerspace department as well. So not to worry, if you don't have your own personal computer, you can just use ours. So here I am. I've got my little file here. This is a file called Benchy. Benchy is nicknamed such because it is a benchmark 3D model. It is one of the best models to use as a torture test for your 3D printer. It has all kinds of different conditions that really stress test your printer, right? You've got arches, you've got this big cantilevering part of the ship. Right, we have this little space in here that doesn't have any supports, and somehow we're going to have a roof on top. So if you ever buy yourself a 3D printer, you're probably going to want to download this file, or it might already come with that file. But so what are we going to do here? The next step after 3D modeling in Rhino is to slice our files. So slicing is the process of converting a 3D model into layers that a 3D printer can understand. The slicer software takes the geometry of the object and generates a toolpath, basically instructions for the printer's nozzle on how to move and extrude material by layer. So here I am cutting through this Benchy file. I've already sliced this file, and now I'm getting a preview of every single layer. So I'm using Bambu Studio first. This is the slicer software for all Bambu Labs printers. I've imported the STL here, and I'm mostly sticking with the default print setting. So if we look here, you can see that we have 200 layers of filament. We can get into all of these settings here, but for the most part, I'm going to stick with some very basic settings. If you're using Bambu Studio to slice your file, one thing you're going to want to make sure you do is you're going to need the correct printers. Okay, the one printer that we have thus far as of 2025 is the Bambu Lab P1S 0.4 nozzle. So if you don't have that system preset, you're going to want to click on select/remove printers. Okay, you'll get this dialog box, and then you have all of these options to choose from for 3D printers. So of course you're going to want to only select the ones that you have access to. Here at OCC we have access to the Bambu Lab P1S 0.4mm nozzle. So go ahead and add that one in. Okay, I've already got mine here, and when you add that in, it's going to come with a bunch of presets. Okay, so if I'm currently using the 0.24mm layer height preset, which is what they call a draft. Okay, so if we look at the spectrum of different presets that we have here, we have extra fine at 0.08 mil, all the way down to extra draft at 0.28 mil. So what that means is the height of every single layer can either be very fine, very small, or it could be kind of fat and kind of thick, and when it's thicker, your file will print faster, right? When it's finer, your file will print slowly, but you'll also get finer details, right? Whereas if you use the extra draft setting, you're going to lose a lot of details. Okay, so I'm going to go ahead and start a brand new project. I'm not going to save this one. Okay, and this is what it looks like when you open up Bambu Studio. You want to make sure you're choosing Bambu Lab P1S 0.4 nozzle. You're going to go to File, Import 3MF, STL, blah, 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 blah. And now I'm going to navigate to where I save that file. That's why it's really important to always know where you put your files and place it intentionally. Here's that file. I can tell by the date. It says, the 17th, which is today, and it's 7:50 when I saved it, so I'm going to hit open. This is an STL file. Okay, that's what this is looking for. These are the only files I can bring in right now. I can't bring in a Rhino model. I'm not going to bring in a DXF or DWG file. None of those. I exported an STL from Rhino, and that's what I'm here to retrieve. So I'm going to select that file and hit open. All right, so I'm getting this dialog box. Object from file 250617 coaster assignment 3D print, TJC, is too small and maybe in meters or inches. Do you want to scale to millimeters? So oftentimes when I'm here in Rhino, I am using measurements or units that I'm very comfortable with, which in this case was imperial units and was inches. Now, when we talk about CNCs and 3D printers and laser cutters, those things are made with such a high tolerance, and typically also from other countries, their primary units are metric. So especially with 3D printing, it likes to only think in metric. So really can't blame them for that. So what we wanted to say is, yes, I do want you to scale to millimeters. I 3D modeled a coaster that is 4 inches in diameter in Rhino. You, Bambu Studio, are looking for a file that was made with metric units, right? So basically what it's done, it's saying that I have a 4 unit wide coaster, and it's understanding it, it's receiving that STL as a 4 unit coaster or a 4 millimeter coaster, and it's thinking, gee, I'm pretty sure you don't want a 4 millimeter coaster. Let me ask. So do I want to scale it to millimeters? Yes you do. And now that's what it looks like. Okay, so now that I have it here, I can see it on the bottom right. It says 4x4 by 1.125, and that's probably because somewhere in my settings I have my preferred units set to imperial. But even if you set it to imperial in almost any slicer, it's still really clinging to the metric unit. So yeah, as you can see here in my preferences for units, I have got imperial, but it really prefers metric no matter what. But I can see here it's reading it as a 4x4 by 0.125 inch coaster. So we're good. So here's my coaster. It's a very simple circle. It's an 1/8 inch thick. It is sitting here on a bamboo textured plate, which we'll get into in a moment. And the next thing I want to do is I want to affect my setting. So right now I'm going to go and start off with, let's just do a, I think I'll start with I'll keep it at 0.24 mil draft. Okay, this is just a prototype for a coaster. I'm not really trying to get anything fancy. And as you can see here, the layer height is set to 0.24 mil. So if I change this to extra fine, that template now gives me a layer height of 0.08 mil. It also changes a few other things, but I'm going to go back to draft. Layer height is set to 0.24 mil. Okay, I can change things like the outer wall, inner wall, top surface. I can generate walls. Here's the strength. I can change the infill, which we can get into later on. I can change the speed. I can enable supports. This is such a simple project, I'm not going to need any supports, but if I had any overhang, I would want to use some support, and I might want to use tree support because it's super efficient. I can use some skirts and brims to help adhere that very first layer to the textured PEI plate. That's always really important with 3D printing, is getting that first layer down pat. However, I'm not going to change any of these settings. So now that I've imported my file, I am using a preset, draft preset. I'm going to go ahead and click Slice Plate. And what Slice Plate does is it'll slice any 3D model that's on this textured plate. And when I say slice, right, you can literally see the many different layers that make up this 3D print. Okay, so the 3D printer is just going back and forth, right? G code is telling it go this way, that way, this way, that way, this way, that way, fill it in this way, fill it in that way, and I have 13 layers based off of the layer height that I chose. I'm going to have 13 layers. So here it is all the way from the bottom. That's going to be my very first layer. And as I slowly move this scroll bar up, I can see every single layer built. This thing also does an amazing job of estimating how much time, what type of material I'm going to be using, and how much material, both in length and also in weight. And I get my totals here. You can also see it says cost right here. You can also associate a cost with your filament, so that way you can get an understanding of how much product you've used, how much plastic filament that you've used. So and then these things right here, 1, 2, 3, 4. We have what is called an AMS. It's an automatic material selector. So we can have up to 4 different spools of PLA. So PLA is just a spool of rolled up plastic. And what happens when we 3D print is that plastic goes into the extruder. The extruder heats it up, and it basically is dripping warm or hot plastic in a very precise pattern, which is dictated by something called G code. And that's what our slicing does, is that we're not only slicing our 3D model, but as it slices it, it's creating a conversation that it's going to have with the 3D printers as to what and where that extruder needs to be. Okay, so now that I've sliced that plate, and I want to click Print Plate. Print Plate is for users who have direct access to their 3D printers, either via the network or via some USB connection. We don't have that luxury here in architecture or in the makerspace. So what you want to do is you want to say Export Plate Sliced File, okay, and then click Export Place Sliced File. Go ahead and click that button. And what it's going to do is it's going to bring up a dialog box where we have to pick where our file is going to go. This is going to be a .gcode.3mf file. So this is what's called G code. So I'm going to put it right here under 2B 3D print. I'm going to click on Save. Okay, Okay, I'm going to open that folder. It's going to help me navigate to where I save that file. And if I expand this, I can see that I have this file, which was my STL that I made at 7:50 p.m. and then this is my G-code. If I open up this G-code in an application like, let's see if I can open it up in Notepad. Okay. Oh, this is not really what I was expecting. Okay, let me close that. Let's see if I can export a different export all sliced file. And let's do it as a, I can't. Let's do file, export G-code maybe? Yeah, all right. I'm gonna export G-code. You don't have to do this. I'm gonna go ahead and do this. Notice one cool thing here too, is as you export this, it's changed the name of my file. It's tacked on some more information. PLA, because it knows I'm gonna use PLA, Bambu PLA on nozzle 1. 29 minutes and 48 seconds. That's how long this coaster is going to take. So really cool. I'm going to go ahead and save that. I'm going to go back to my folder. Here's that new G-code file. I'm going to open it up. Let's do it with Notepad. There we go. That's what I was looking for. This is what G-code looks like. What you have are there's a whole syntax of commands, a whole library of different commands that G-code is accessing during this procedure, and it's outputting this as basically a text file, and this text file is going into the 3D printer, and the 3D printer is reading it, right? Think of it as like robot language. So the slicer creates this language. It says, hey, grab the extruder, heat it up, move it from this point to that point, to this point, to this point, to that point. We're going to go up 13 layers to get this done. And this is how long the G-code file is. Okay, that's all the G-code right there. G1 X943871Y8794E.25524. So if I had to guess, G1 is moving the extruder head. This is your X value, this is your Y value. This has to do with extrusion speed, if I had to guess. Here's a wipe start, here's a wipe end. So the Bambus will actually go and wipe their extruder head so that way it gets cleaned off every layer. So that's all G-code. I'm not even halfway through this G-code file, and this is just for a simple, tiny little coaster. So imagine something way larger. Okay, this is for a 4-inch, 8 by 8 inch coaster. Okay, so I'm going to close that. I don't need that right now. I really don't need this in general, so I'm going to go ahead and delete that. And this is the file that I'm going to need. You're going to want to make sure to have this special little adapter. Okay, on one side it hooks up to a USB-C port, and on the other side just a regular USB. This is a 3.0 port. So pick one of these up, because you can put a memory card into here, or memory card adapter / reader, and you can also put in a micro SD card, which is the main way that we are going to transfer our files from this slicer, this G-code file, and we're going to put it into the Bambu. It receives it via a small, teeny tiny micro SD card. So you're going to need this. You put the micro SD card in here, then you put this flash drive into your computer, put this specific file onto that micro SD card, eject it all out, go to the 3D printer, put the micro SD card in there, and then you can start printing your file. So that's how you do it for Bambu, and I'll go over how to do it real quick with the Ultimaker Cura. It's super similar. The only difference here is that when you add printer, choose Ultimaker Printer, add a local printer, and I'm just going to go to add a non-networked printer, just because we're not going to hook up to these 3D printers via a network connection or USB. We're going to do it again by flash drive. So there are two Ultimakers that we have in the makerspace for you to use. Ultimaker 3 and Ultimaker S5. Okay, so choose one of those two. I'll reiterate. Ultimaker S5 and Ultimaker 3. Not S3, not 5, but Ultimaker 3 and Ultimaker S5. The reason why I want to bring up both of these slicing methods is because that's our unique situation here at Orange Coast College, is we have basically three different 3D printers that we could utilize. Now the Bambus are probably the most popular ones. They're the newest ones we have. They're relatively affordable, but they're also really fast and really good. The Ultimakers now are a little out of date, and they're a little slower, a little clunkier. But because of the popularity of our Bambus and us having a limited amount of them, you may or may not get to use a Bambu, right? They're so popular, everybody's going to be using it. So you want to be prepared to be able to slice for either Ultimaker Cura or for Bambu. So Ultimaker 3 is the smaller printer, looks like this size, and then Ultimaker S5 is the larger one in the makerspace. So that's the size of it. You can pick between one of two spools of filament. You want to make sure to dictate this early on when you're slicing this file. So let's go ahead and go File. Let's do a new project. I'm not going to save anything. I'm going to go File. I'm going to import in Ultimaker Cura, you have to open a file. So I'm going to go to Open File. And I'm going to find my file. I've placed it in this folder, and I want to make sure not to grab the G code that I just created. That's for the Bambu. I want to grab my STL, which is this one here. Okay. It's imported, but you probably can't even tell, right? Here it is. Remember the issue that we had previously with Bambu? One of the first things it asked us was, hey, are you sure you didn't mean imperial units? Because I can scale this for you to millimeters, because I've imported this as 4 units, which in my world is 4 millimeters. So the size of this thing, if I go to scale, is 4 millimeters, which is completely wrong. So a couple things you can do when you're in Rhino and you're 3D modeling. Right when you get to the end, you can switch your units to millimeters and then export it as an STL while you're using millimeters, right? You've just converted from inches to millimeters. You've kept the scaling, the size of that file in Rhino, and now you're exporting it as its millimeter equivalent. And when you open it up, its millimeter equivalent will be equal to your 4-inch diameter that you're seeking. However, another process that you can do is, if you don't want to touch that, then you can just scale it up. Okay. Oh, also, if you go that route where you're in Rhino and you 3D model it in Imperial, and then you switch quickly to metric to export it, after you've made that export, you can undo as far as you can to go back to Imperial. So that way you don't change your file, you're not stuck in millimeters all the time. Okay, so now what we want to do is we want to scale this up. So how do we scale this teeny tiny little 4 millimeter thing to be 4 inches? Well, first we have to select it. We have to select the scale tool, and then we got to figure out, how do we scale from 4 millimeters to 4 inches? So let's type in 4 millimeter to 4 inch I don't know, conversion. Okay, so we're going from 4 millimeters, and we're seeking 4 inches. Or actually, let's swap. Let's say we want 4 inches and convert it into millimeters. So in millimeters, 4 inches is equal to 101.6, and the calculation is 4 inches times 25.4. That gets you your 101.6 mil. So if I go back to Bambu, or I'm sorry, Ultimaker Cura, I can either scale up by changing the X, Y, or Z values, which are here in metric, or I can scale it up percentage-wise. So let's do it first by changing the value. So we know 101.6 is what we really want. Make sure you have uniform scaling on, otherwise you're just going to stretch it out in one direction. So instead of 4 mil, we're going to paste in 101.6. Uniform scaling is on. I'm going to hit tab, and voila. Okay, now that's looking better, right? That looks like about 4 inches. Okay. Also, if I undo that, if the other way to do it would be to scale it up in a percentage of 2540, and that gets me my X, proper Y. Okay, so 2540 is the conversion from millimeter to inch. Okay, so either way works. Okay, and it's this Ultimaker Cura is very similar to Bambu. It's just things are in different places and the interface looks a little bit different. Okay, so we have our Ultimaker S5, which is the bigger one in the makerspace. We have our different presets. They're called profiles here. I'm just going to keep it at fast. When we're 3D printing, we're usually prototyping things. We're not always making something that can be used in a final condition. A lot of times we're just prototyping these ideas, so we don't need to go really slow and really fine. You also want to choose which spool of PLA, because there's 2 possible spools that you can have loaded up on a Ultimaker, and this is where you dictate which one you use. So make sure you're looking to see which spool is there on the printers and which colors are there. Right? Just because I choose blue here doesn't mean like blue is going to magically walk over there and load itself up on those printers. You actually have to load these properly. So inversely, if you just choose one, right, and you set up your layer heights and everything and walk over to the printer, you just need to mentally take a little note and say, I need to make sure I have a proper amount of PLA loaded up onto a spool on this Ultimaker S5 on spool number 1. So I'm going to leave all of these settings here. I'm going to click on slice. All right, it's going to take 1 hour and 25 minutes. Compare that to Bambu, who is going to do it in 29 minutes and 48 seconds. So a pretty big difference. Let's see, that's a 0.2 mil height here, layer height here in Ultimaker Cura. Let me go back to Bambu so I can get a fair. So it's 0.24. So let's set it to 0.2 mil standard, just to compare. Let's slice the plate. 30 minutes 41 seconds. So still, you know, way faster using the Ultimaker Cura. So now that I have sliced it, I can preview it. Right, here's my little play button. I can hit play. It's showing me every single layer that is going to occur. I've got 16 layers with the 0.2 mil layer height, and I can fast forward this all the way to the end, and voila. So now I want to save to disk, and with the Ultimakers, you need to put this file onto a flash drive. So instead of a micro SD card, you need a thumb drive, just a regular old thumb drive. So I don't have one here, so I'm just going to save it onto this folder here under coaster, under 3D print, and it's always going to name it as a UMS5 file. And when you use the S5, it actually packages it up as a compressed folder, like a very special type of compressed folder. And then when you use the 3, it just creates a G-code file. So same thing, you just load this file onto your flash drive, take your flash drive, walk on over to the makerspace, check to make sure you have good filament, make sure it's not brittle and breaking easily, and then make sure you have a clean plate. Go ahead and insert your flash drive into the printer, and then go ahead and hit print, and then you're ready to go. So I'm going to save this file here. Okay, and you can also save this Ultimaker Cura file as well, just for your own records. I'm not going to, but you're more than welcome to. That way you can come back in here and reslice it. I'm going to hit close. Same thing with Bambu Studio. You can, save this file. I'm going to hit close. I'm not going to save it. All right, that's all ready to go. Good luck. Hope your prints turn out well. Talk to you later.